In the real world, it can be very useful to determine maximum and minimum values. For example, if you own a company, it would be beneficial to know when your company reached its maximum profit. Or perhaps you want to know when the company reached its minimum cost. So analyzing graphs and finding maximum and minimum values is going to be useful for us. So let's talk about a relative maximum or minimum. And the word relative could also be replaced with the word local. Those are interchangeable. It really just depends on the person that you're talking with or the book you're reading or the video you're watching. When they refer to a relative minimum, that could also be called a local minimum. Those words are interchangeable. So a relative max, if we look at this graph, we have a relative max right here at a comma f of a, and you'll see that as a peak in the graph or a high point in the graph. Basically on this graph, we can see that my graph, it's increasing, and then my graph begins to decrease. So my y values are increasing and then they decrease. We've reached a point that is a relative or a local maximum. Now, it's not the absolute highest point on the graph because of this arrow on the far right-hand side. This is indicating, of course, that the graph is going to continue upward. So this is why we call it a relative or a local max and not an absolute max, because it isn't the absolute highest point on the entire graph, not necessarily, but it is a high point. Now let me break down the way this is mathematically written because I know that the symbols can be confusing. This says that f of a is greater than or equal to f of x for all x near a. So what does that mean? Basically, that means as long as I'm in this little neighborhood here around x equals a, so I'm kind of close by in this little neighborhood, so we're only analyzing this little section of the graph, that the y value here at f of a, this y value, it's larger than the y values around it. So that's why we say f of a is greater than or equal to f of x, meaning that my y value at f of a, it is greater than or equal to the y values around it when we're in this little neighborhood where x is near a. And then the same is true for a relative or a local minimum. So this reads that f of b is less than or equal to f of x for all x near b. So same idea here. If we're just somewhere close to x equals b, so somewhere in this little neighborhood, and we're looking at this y value, so if I were to come across and analyze this y value here, this y value would be the value of f of b. We see that this y value, it is less than or equal to all of the other y values around it. So again, if you're just in the little neighborhood here around x equals b, you can see that f of b, that y value, it is less than or equal to the y values around it, and that's what makes us have a relative minimum, also called a local minimum.